Hello, Mrs. Hightower here, doing the first demonstration for us. And what I'm going to do first is put on my goggles because we are working with some dangerous chemicals here, so I do need to protect my eyes. And so once we're back in person, you too will be wearing goggles during our labs that we should be having about once a week. So I'm also putting on gloves because the chemical I'm using, hydrogen peroxide, is a lot stronger than what you buy at CVS to pour on your scrapes and scratches. That is 3% concentration, and this is 30% concentration. So this will eat the skin off of your hand if it gets on it. So we need to be very careful. So I'm going to pour 100 mLs of hydrogen peroxide, 30%. Put the lid back on to be safe. So I've gotten that poured. Now, just so we can see our demonstration a little bit better, I'm going to put some food dye in the flask. So I have a very large, we would call this an Erlenmeyer flask. Not that you need to remember that name, it's kind of a weird name, but to just remember it's a flask. Something that we do, a lot of times they're shaped like this, triangular. We're going to do a bunch of our experiments in them. So, right now, I'm going to pour my hydrogen peroxide in. And nothing really happens because it's just some hydrogen peroxide, some food dye, and a little bit of dish soap. But now you're going to see why we call this elephant toothpaste. Okay, now I'm going to add in a catalyst and let's see what happens. Woo! There we go. Can you see? I think we can see up here, we can also see some steam. So we know that it got very warm in that chemical reaction, which is a common thing we see in chemical reactions is sometimes they'll get hot or sometimes they'll get colder. Okay, I'm just cleaning up here a little bit so that I can move my camera. And not get it dirty. Where's my trash can? There's the other trash can. Okay, so that was our whole demonstration. You can see why we call it elephant toothpaste because it looks big and foamy, like it could clean even an elephant's mouth. So what I want us to look at now is at the reaction on the board. So I'm going to need to pause this and switch the video to not be selfie mode. Okay, it looks like I have focused on my chemical reaction on the board here. So hopefully some of us remember from 8th grade how to balance chemical reactions. So what we do is, the easiest way is to write a little reactants and products table and count how many atoms we have of each element. So we only have 2 elements here. We're not going to include sodium iodide because that is our catalyst. It just sped up the reaction, but it's not part of the reactants or the products. So we're going to count. We have 2 hydrogens and 2 oxygens in our reactants, and then we have 2 hydrogens and 3 oxygens in our products. So since we know we always have hydrogen in pairs, we know that we're going to have to make this an even number. So the lowest even number we could try is 2. So we'll try a 2, and then we're going to adjust our table. So now in the products, we have 4 hydrogens and we have 4 oxygens. Okay, so we don't match the reactants, but we can see this is obviously 4 is a multiple of 2, so we can put a 2 here. And then now we are balanced. We have 4 in the reactants, 4 in the products. 4 oxygens in the reactants, 4 in the products. So this is H2O2 is our formula for hydrogen peroxide. And then hopefully we remember H2O is water and O2 is oxygen gas. Now we could leave this blank, or we could put the 1. It's implied 1, just like in algebra. 1x is the same as x. Okay, so we have our balanced chemical reaction now, and then heat was produced, so we know that heat will be on the on the product side of the equation. Okay, so we know that we produced heat, and we call that exothermic. Okay, exo outside, and thermic relating to the temperature or the thermic capacity. Okay, great.